Hey you guys, so of course another air puzzle video, but this one isn't going to take us long, so you guys will see that shortly. So what we're going to be doing for here is just going to be taking a look at vertex form. So I know we've covered standard form extensively, but we haven't had a lot of time to talk about vertex form. So I just want to make sure that we are comfortable identifying those key features in vertex form as well, specifically the axis of symmetry and then the vertex. So notice the name of this form is called vertex form. So to find the vertex, I would think it's going to be quite simple, quite straightforward. And look, take a look over here. It says ax minus h squared plus k. From that form, our vertex is just going to be h and then whatever k is. So whatever this number is here, and we also need to make sure that we have the minus out front before we assume that this is going to be RH. And then whatever our constant is at the end, that K represents our Y coordinate of our vertex. So what do you notice about vertex form? It easily tells us our vertex. Okay. So we're going to take a look down at these three different graphs, and then we're going to see if we can match up the form. And all we really need to do is just take a look at whatever the form is suggesting the vertex is. So what I want to do first is I'm going to go ahead and label out each vertex. And I know I'm going to do that with x comma y, and I'm going to just write that up here as a kind of a reminder for us, x comma y. So if I'm taking a look at this first point right here, this purple one, I know that this is going to be 3 comma negative 8. That's the vertex there. And then if I take a look at this next one, I'm going to make this blue. I see that this is on our x-axis, so it doesn't have a y value. So this is just 2 comma 0. And then our last one over here is above our x-axis, so I know I'm going to have a positive y. And then this is a negative 1 comma 4. And I said negative 1 because it's to the left in our coordinate plane. So we found our three different vertexes. I'm going to call them all different colors, so it's going to be easy to pair them. So my first vertex is 3 comma negative 8. So that means inside of my parentheses, I need to make sure that I'm seeing x minus 3, because this would be the h. Now there's only one set of parentheses that shows me that x minus 3 that I'm looking for. And that's specifically this one right here, this b. I'm acting like you guys can see what I'm pointing at. But that b right there, notice how it has x minus 3, and then it also has that negative 8 constant that we were looking for. So I'm going to go ahead and say that this is for b. Trying to clear some things up. And then let's take a look at this second one. I know I have 2 comma 0. So I know in my parentheses, I'm going to want to see x minus 2. And that's only because we said that our x value for our vertex is going to be 2. So it was kind of helpful to identify it on the graph first. So now when we go into vertex form, we know exactly what we need to look for. So if I'm looking at my answer choices, there's only one answer that has the minus 2 in that parentheses, what I'm looking for. And notice how it doesn't have that, how that answer choice also doesn't have anything at the end. Our y value for our vertex was a 0. So it doesn't make sense for us to say, it doesn't make sense for us to write it like that. Because plus 0 is the same thing as saying plus nothing, so it's just kind of redundant. So we're just going to go ahead and erase that plus 0. And we will write it in our simplest form, which would be the way that it's presented in format C. So now we have one more to take a look at. And that's going to be this last one. We already said the vertex was minus 1 comma 4. So I know when I put that into my parentheses, I know I need to look for x minus negative 1. Because this right here is the x value of our vertex. If I were to simplify this, I know when I have a minus next to a minus that that's going to turn into addition. So this is essentially x plus 1 squared. So now I need to figure out where do I see that in a set of parentheses. And actually it's that first one right here. And notice the plus 4 at the end reflects the 4 that we had as the y value for our vertex. So choice A does correspond with graph number 3. Now, I know we just took a look at all of these examples and labeled the vertex according to the graph, but I want to make sure that we're able to do that when we don't even have the graph with us. So we know the general format for standard form is going to be ax minus h squared plus k. And that vertex is just h comma k. So notice in this first equation here, I'm looking here, I have a plus 1. That isn't the form. That isn't the form. So I need to write this equation out with a minus in it so I can clearly see what that vertex is. So if I were to rewrite this, I would say negative 2x minus negative 1 squared plus 4. And these are equivalent expressions. Now I can clearly see what the vertex is. It's going to be negative 1 comma 4. So notice that whenever you have that plus sign inside of your vertex form, your vertex is going to be the reverse of that number because vertex form tells us for x minus h. So we need to make sure that we're in that form before we want to jump to conclusions. We need to be in that x minus h format. So take a look at B. We can clearly see the difference. I'm already with that x minus h format. So I know h is just 3. My constant is just negative 8. So that works pretty straightforward. And then if I take a look here at C, I see I have that x minus h format. My x value is just 2. And notice I don't have anything at the end, so the y value is 0. So as you can see, in vertex form, it's really straightforward to find the vertex. And that does make sense because, hence the word vertex form. But anyway, I'm going to come down here and look at how to find the axis of symmetry. And you guys, this is going to be so straightforward. It says, given a quadratic function in our vertex form, the axis of symmetry is the vertical line x is equal to h. Look at this. I'm going to take a look at this one here. If I zoom in, I can clearly see, okay, notice the axis of symmetry is going to be that vertical line that makes the left-hand side of the parabola look exactly like the right-hand side. So we're trying to figure out where can we put a line so that we can mirror either side of that parabola. I know I can do that right here. That line of x equals 2 literally makes that left-hand side look just like the right-hand side. The notes below told me that the axis of symmetry is equal to the line x is equal to h. In this format here, we had already identified h to be 2. We said h was 2 here. And notice that's the exact line that's our axis of symmetry. So whatever our x value is for the vertex, that's our line that represents our axis of symmetry. So I'm going to come down here and let you guys take a look. So we said the axis of symmetry is equal to x, well, let me put a colon. It's equal to x, where the line is x is equal to h. Here, we already said, well, we didn't do this example yet, but we can clearly see that h here is a positive 5. That's our axis of symmetry, you guys. And if we were to go to Desmos and graph this, we would see that the line x equals 5 makes the left-hand side look exactly like the right-hand side. So I'm going to go ahead and just tell them that the axis of symmetry is x equals 5. Now we have to do the same thing with part B. I'm going to go ahead and verify that it's in my format x minus h. It is. So my axis of symmetry line is just x equals to 9. So vertex form really gives us these key features without the hassle of doing the A, B, and C. So it's a really straightforward method. And for C, okay. So I know I don't see that minus. I know the general format is x minus h. I don't see that right here. So before I even want to make any assumptions, jump to any conclusions, I need to put this in the format with a minus sign. And I know I can do that like this. So I would do x minus negative 4. And I know that these are equivalent expressions because a minus next to a minus is going to give me a positive. So these are all the same things. So I can clearly see what that h is. That h is a negative 4. So right here, the axis of symmetry is x equals negative 4. And if we wanted to go a step further and find the vertex, I already know what the y value is. I know what the x value is for my vertex. That's negative 4. And can you guys tell me what the y value would be? I'm going to leave that as a question for the ed puzzle. So I told you guys this is a pretty straightforward video. We have one more section to cover for this ed puzzle. We need to figure out how do we go between vertex and standard form. These two equations, they don't exist in isolation. We can call them cousins, best friends, or whatever works for you. So what I'm trying to say is we can easily go from vertex form to standard form. And I'm going to show you guys how to do this. It's going to just be a recollection back to unit 1 when we were using multiplying binomials. That's literally what we're going to do right here. So first, I'm going to just go ahead and write out this squared term. So I know I'm going to have x plus 2 twice, because that's what squared means. Then I'm going to do my minus 1 at the end. So I'm going to go ahead and FOIL this out. So my first terms would give me an x squared. My inner terms would give me a plus 2x. My outer terms would as well. I did that backwards. Hopefully you guys caught that. And then the last terms would give me a plus 4. At the end, I have to make sure I tack on that minus 1. It doesn't just vanish. It's still a part of our equation. Now, we're going to combine those like terms, which you guys already know how to do from unit 1. So I know that these two go together, this plus 2x and this plus 2x, because they're both x terms. And I'm also going to combine this 4 with this minus 1, because those are both just regular integers. Once I do that, I get x squared plus 4x plus 3. And y'all, this is standard form. This is standard form. I see my ax squared, I see my bx, and I see my c. So as an extension, I'm going to go ahead and have you guys figure out what's the a, what's the b, what's the c. I know you guys are probably tired of doing that, but practice definitely makes perfect. So I'm going to go ahead and have us look at b now. And we're literally just going to do the same thing. What I'm going to do first, I'm going to expand out my squared term. So I'm just going to write it twice, because I know that's what squared means. So x minus 5, and then x minus 5 again. At the end, we need to make sure that we're tacking on that plus 3. So I'm going to just go ahead and put that at the end so we don't forget about it. Now I have to just FOIL this out. So x times x, that gives me x squared. That's my first term. Then my outer terms, I have an x with a minus 5. That gives me minus 5x. I see the same things happen with my inner terms. So I have another one. And then my last terms, I have a negative 5 times a negative 5. So that's plus 25. And then I can't forget about my 3 at the end. So that's why it was helpful for me to go ahead and write that up top, because I don't want to get too far into my equation and then I'm wondering where did terms go. So let's just make sure that we're being consistent when we're writing these up. So I have my plus 3 at the end. Now we just got to combine those terms again. So I got x squared first. Minus 5x, that's going to make me a more negative 5x. So I'm going to minus 10x. So notice we had a negative 5 minus 5. So if you already owe me $5 and now you owe me 5 more, you're more in debt. And then at the end, I have that plus 25 with the plus 3. So I know there's just going to be a plus 28. So I'm going to go ahead and let you guys label out the A, B, and C here. Please be cautious of your signs. All right, this is our last one, you guys, last one. Let's take a look at C. So we already know the steps. That's what I like about math. Numbers can change, my process stays the same. What did we do first? We took everything we saw in the equation, we wrote that first. So I have my 2 out front. So notice my other ones didn't have an A out front. So there was no need to do so. But here, we're going to put that 2 out front. Then I have my x plus 3 with another x plus 3. And then this is all added to 4. What I want us to do first is I want us to focus here. I want us to focus right there. Let's multiply these binomials out, and then we'll come back and get that 2. Because I don't want us to do that first and kind of get some signs confused or miss out on some things. So let's handle out this binomial multiplication first, and then we'll come back and multiply it by 2. So my first terms are going to give me x squared. Inner terms are going to give me a plus 3x. Outer ones will as well. And then my last ones are going to give me that plus 9, because 3 times 3 is 9. Now don't forget, I said we're going to come back and get that 2. So now it's a little bit straightforward, because we're just going to take this 2 and multiply it with everything in its parentheses. So now I have a 2x squared plus a 6x, and then another 6x, and then plus 18. Now I can combine these terms. So I have a 2x squared plus 12x plus 18. Now hopefully you guys notice that we're missing something. We can't forget about our little 4 over here, because now I can just kind of combine everything together. So my 18 and my 4 are going to be the only terms that I can simplify. 18 plus 4 is 22. So I'm going to go ahead and go out and write 2x squared plus 12x plus 22. And this is the final step. This is my final answer. So I took this from Vertex form, which was up here in the yellow, did some multiplication, manipulation, and I ended down here with standard form. So once I graph these two different parabolas, I'm going to get the same line. They're the same equation, just written in different ways. So mashed potatoes, french fries, both potatoes, just in different ways. Same thing. So I'm going to go ahead and let you guys label out A, B, and C. And that'll be the last question for this ed puzzle. And I do want you guys to know that we could have simplified this purple first and then did the distribution of the 2, or we could have did it the way that we done as well. So that's another thing, the beauty of math. Different ways, different methods can get us to the same answer. We just have to make sure our process is consistent. Okay, so I'm done with this ed puzzle, but as always, please feel free to reach out if you guys have any questions. Take care, okay? See you guys next time.